Alright guys, so what I've done so far, I've taken the BQ chip off once again. Yeah, I was doing some research and checking just around, probing around to see what was happening. So that's the BQ chip which I had put to replace onto this motherboard. As you can see there, BQ24780s. Alright, and this is the original BQ chip right over here. BQ24780s, again, same number. So yeah, as you can see, I've been looking at the schematic diagram of this thing right over there. Yeah, that's it. And then over there, I was looking at the board view on the other screen, that side. Where is it? Okay, on that screen over there, that you see moving up and down over there. So yeah. Anyways, from just looking at the schematic diagram and checking what we know about the BQIC, I hope it's clear. There's no need for me to do screen capture. I just hope that it's clear enough. So let me zoom out over here. This is our BQIC right over here. Is it clear? Alright, so the BQIC basically needs power to come into the chip, which is over there, VCC, and then it also needs just zoomed in over there, VCC, that's pin number 28, and then it also needs AC detect, which is pin number 6. As you can see, when I pulled up this page, it was highlighted over there on AC detect there, which was pin number 6. So AC detect has to be like around 2.4 to 3 volts. In this case I'm getting 3.6 volts, but I guess that's okay. And I measured the resistor, which is 432 kilo ohms. When I measured it also on the motherboard, it's around 400 kilo ohms. Yeah, and it keeps rising, but then now it will be rising slow. So yeah, I didn't have to wait for it to get to 32. And I'm getting the 3.6 volts here on AC detect. However, for you to know that the PQIC has received the 2 signals and it's active and working, it should give out AC OK here, right over here, which is pin number 5. But on this particular case, AC OK is nothing. Nothing was coming out on AC OK, even though I'm getting VCC in and I'm getting AC detect, but there was nothing on VCC. So what I've done is I've taken the PQIC off and just looked around the PQ chip to see what is happening. So let me turn the monitor like this. I'm pretty sure it's much more clear now. Alright, I'm avoiding having to record on a lot of screens, man. Then it sucks. Then I have to sit down and compile a video. That's gonna take me time, and trust me, you won't get any updates at all because I'll never have time. I think I've got more than 15 projects which I just need to edit. I end up deleting the videos because they'll be wasting my space. Anyways, this is a BQIC, so these are all the pins of the BQIC, which are 29. There are 28 actually, and then pin number 29 would be this one, the central pin. That is our ground. So according to the schematic and according to all the knowledge that you have about a BQIC, all of these are positive. You only have got one ground, which is over here. That is your pin number. Let me check on the board view. That's pin number 1. On the board view, that's pin number. I keep forgetting. It's pin number 22, which is ground. So this is ground. That's normal. So if I measure here, there is no ground at all. Okay, that's 10 ohm. That's 10 ohm over there. It's not ground, it's just low resistance. So I would question this resistor because this is ground over here. Yeah, this is ground, and now I'm getting 10 ohm over here. And when we're checking there, that is pin number 17, which says battery SRC charge 1. Okay, we're gonna come back to that. And then we move on. There is nothing. When we come and check this side, there's nothing happening over there. Let me rather focus the microscope. It's not focused properly. Alright, cool, there we go. So we've got nothing over here. I'm just making sure that this phone is recording. I usually talk a lot like this and then I realize I didn't press record, or someone tried to call me and then when it stopped ringing, then it just stops recording. So checking this side, what do we have? We've got another beep over here, right over here on the, and that's 0 ohm. So is this one. This is also 0 ohm. So we've got 0 ohms right over here by these 2 pins. And what are those? Those are pin number 1 and 2, which is ACP1 and ACN1. So when it's like that, it simply means we've got a short circuit on our main power rail. But if you remember well, we didn't have a short circuit on the main power rail. We did not have a short circuit on the main power rail at all. But now we've got a short circuit. So one thing that I noticed when I took this motherboard off, when I took the BQ IC off, the first thing that I noticed was that I was getting 0 ohm over here, right over there. That is what I wanted to show you. All these other ground pins that I'm now finding, they were not there. I'm just finding them now. Anyways, there, that's the one. So that's 0 ohm. And when we check, that's pin number 27, which is LX charge 1. And when you flip it around, when you follow this, it will take you down to the, let me see if I can pull the board view this side, because where it is over there, you won't be able to see even if I zoom in. Alright, so pin number 27, when we check it out on the other side, it takes us to here where we've got PL8501, this guy over here, which is an inductor. So that's the inductor that takes us to the battery. Yeah, that's the inductor that takes us to the battery. Yeah, and when we try to zoom, it'll come like this. How does it get to the battery, by the way? It gets to the battery via this MOSFET over here, and the output of this MOSFET, I believe, goes to the battery some way or another. Yes, it comes to the battery. So when we check on the battery connector itself, we do not have a short. We do not have a short on the battery connector. That's fine. But we do have a short on this inductor over here, and it's 0 ohms. So what I'm going to do is I'm going to inject voltage. And also now when we check this side, I believe we've got a short circuit. Yeah, now we've got a short circuit here. So I would assume it has to be a chip which relates to that inductor as well as main power rail. So that can only be the charging MOSFET for the battery. Yeah. It has to be the charging MOSFET for the battery. The reason why I say that, it is a dual MOSFET anyways, so it's not just one MOSFET. So on the other hand, it will be going to this inductor, and on the other hand, it will be going to the main power rail. Let me see. That says battery, what I want, and then it must have ground at the same time. So let me check this side. This takes us here. That takes us to ground. And that takes us to the main power. So it has to be this MOSFET that's dead, because this is VIN20, as you can see over there. VIN20. Let me try to switch off this light. I think it's the one that's causing the reflection there. Not what light is that? Oh, it's this one. Let me rather lower it. No, it's not. Oh, it's the light on device desk way that side. That's far. Anyways, this is VIN20 there. That's our main power rail over there, which you see VIN20. And then when we check this side on the same MOSFET, that is ground. That is our ground there. You can see GND1. And then when we check the central pin, which is the output of this MOSFET, that is our inductor where we've got a short. So I've got a short circuit on this inductor, and remember, I've got a short circuit on the main power rail. The only thing that links those two together, it's this dual MOSFET. So under normal circumstances, you would have two MOSFETs, one high side MOSFET and one low side MOSFET, and then where they meet at the center, it's the output that goes to an inductor. So in this case, they put those two into one component, into one package rather. So let's take that MOSFET off. I think I've explained enough for you guys to understand. So let's rather take this MOSFET off, and we see the result from there, if we are winning or not. So it is BQ24780s, which is right there next to the inductor. Alright, do I need flux for this? Not really, but yeah, I'm just gonna add flux to make things flow much easier. But otherwise we don't really need flux for this. Let's take this MOSFET off. So in this video, if you notice, I've been pretty much wasting time on a lot of unnecessary information, which most of you guys know, but I'm just thinking, man, that there's always someone new. Yeah, there's always someone new, so it's just wise to always try and recap so that we accommodate everyone. There you can see the short circuit is gone. That's ground. Short circuit is gone. When we check on our main power on this side, short circuit is gone. So now let's come back to the BQIC. This is our BQIC. I'd rather view this from the microscope's point of view. Let me lock it in. Okay. Right, and let me focus the microscope onto this area over there. Right, there we go. So that's the BQIC over there. No, it's not the chip itself, but it's where it sits. So let's check again. Do we still have a short circuit? We no longer have a short circuit on these two pins, so now we're clear over here. This side we were clear, right? We didn't have any short. Then we had a little we had a 10 ohm resistance right over here. Now we're clear. And then we had a resistance over here by pin number 27. Now we're okay. So we're left with just one ground. The rest, they are now fine. They were being caused by one MOSFET. So I don't know, man. I don't think this MOSFET was dead in the first place, because we didn't have a short circuit on the main power. Or we could have had a short circuit on the low side of the MOSFET. So the MOSFET probably was dead and it was having a short circuit on its low side, which caused the device not to switch on, because it detects that there's a short circuit somewhere. Remember, the BQIC is responsible for all the incoming power, whether from the charger or from the battery. So if it detects a short circuit somewhere along those circuits, it will switch off everything else, like everything else. So it was having a short circuit on its low side, which we didn't see because it was on the inductor. But then over a period of time, having to connect and disconnect the BQIC, keep powering it on and off. Probably when I was forcing it to start, when I was forcing voltage to come from the charger to the main power, probably the high side also failed, which later on introduced that short circuit, or not only from the inductor but to the main power as well. So that's probably what happened. That's just me theorizing there. That looks fine, and let's see the other side. That looks okay. Let's check this side. That looks fine. I'm just going to introduce more light. This is yellow light here. I'm going to try to change it to white. Can I change it to white? Yeah, now that's white light. And that looks fine. I think you guys can see that. Let's see this side now, and then try to focus. That looks fine. All this is not necessary, really. Yeah, if I check it and I say it's fine, then it's fine. There's no need for me to like start checking all the sides and showing them. If you notice, I didn't replace that MOSFET. It doesn't really matter because it's just for charging the battery. So even if it's not there, the machine should be able to switch on. So now I've plugged the charger, and I still do not have any current draw from the charger there, from the power supply. Let me see. still have got 18.91 volts over there. What am I now getting here by ACOK? My ACOK is still off, and my AC detect still now I'm getting 3.5. I was getting 3.6, but then that's still fine, that's still okay. So ACOK, I'm still getting nothing at all, like zero. So that basically means nothing else is going to be activated. Alright, I'm gonna just replace that MOSFET. It's a dual MOSFET. I'll replace it for now just to confirm if maybe probably this device needs to have everything present before it activates anything else. So I'm gonna take the dual MOSFET from an E15 motherboard here. Right over here, that's a dual MOSFET. I know I've replaced this quite a few times. You know, I've replaced these not because they were faulty, but because I've had a long spell of beeping E15s. So I'll try to figure out exactly what's causing that thing, and I still haven't found out yet. Yeah, it's a disease, man, where E15 just starts beeping. It beeps, it doesn't really do anything else. Alright, let's put this MOSFET over here, and then we can test. So this time, before I plug the charger, I'm just gonna make sure that we don't have a short on this inductor. Right, let's see. Yep, we still don't have a short. We're fine. This is our ground side, and this is our high side, which is our VIN 20. So let's plug a charger. Nope, no response whatsoever. There is no response at all. So yeah, there's no response. I do have my 20 volts coming in from, oh no, it saw a response. I saw a response there. I saw it respond. For a moment it responded there. I don't know, maybe it's just that yeah. Nope, there is 0 volts over here. Oh, sorry. Yeah, oh yeah, it's fine. There is 0 volts right over here. 0, 0, 0. But I've got 20 coming in from the charger, 19.6 coming in from the charger, and 0 right over there. And when we check on the PQIC, we've got 18.99. It's pretty low, man. This is not supposed to be like this. I don't know why it's giving me 18.89, and yet I'm getting 19 coming in. Let me just try to jump this diode and see if that makes a difference. I doubt it does, because this PQIC is supposed to activate with any voltage starting from 4 volts up to 25. It should activate anyways. So what I'm going to do is, I've got a motherboard over here. This motherboard responds. It gives me 25 volts and everything. It's just got a dead PCH, so it won't start. But otherwise it does respond to a charger, and it's drawing like 120 milliamps over there. Check, we've got 19 coming in, 19 coming out there, and then 19 on the main power rail. When we check on pin number 4 over here, we've got 25.57, and when we check over there, we've got the same thing. Alright, so where's the PQIC for this? The PQIC is sitting right over here, right over there. So when I check, which this is pin number 28, I've got 19.34 coming in, unlike on this motherboard where I'm getting 18. And then I need pin number 5 and pin number, I'm going to try to see clearly on the microscope over there. So I need pin number 5 and pin number 6, I think, wasn't it? I think that was it. 1, 2, 3, 4, 5, which would be ACOK. I want to see if I'm getting any output over there. I've got 3.3 volts coming out of that. Just going to confirm which one is that. AC OK, which was pin number 5, and then pin number 6 was AC detect. So AC detect would be pin number 6, so that would be 1, 2, 3, 4, 5, 6. AC detect, I've got 2.6 volts. Unlike that side, I've got 3.6 volts. Here I've got 2.6, which is within the range. So remember the range, they said it has to be within 3 point, they said what? They said it's 2.4 and 3 volts, and I'm getting 3.6 volts. So it might be the issue on that motherboard that AC detect is quite a lot. It's quite high, so it's out of range. Therefore, we do not get AC OK. So here we've got AC OK, which is 3.3 volts. Fine. Let's just confirm by taking this BQIC. We know that it's working 100% fine. We replace it on this motherboard. See what we get. We might be lucky. So this is one of those videos where I'm not fixing something that I know, that I'm just learning basically. And it's a long process. Trust me, you do not want to be my customer when I learn. Yeah, I know other technicians would agree with me. When you learn something, you are going to charge. The other customers, they'll be fine. Well, once I know the solution to a problem, yeah, everyone who comes later on will be okay. And I forgot I was programming a battery over here. I unsealed the battery and I didn't clear errors. I don't know how long it takes for it to seal on its own, or if it waits for you to give a command, then it will seal. That's completely off topic anyways. So take this BQIC off. Hey, come on. You need that much heat. Okay. Oh, come on. Now what have I done? Yeah, that's the right orientation. This should sit like this. Oh, come on. I was sitting so perfectly. I don't know how it did, and then it just jumped off the motherboard. Okay, surface tension should be able to pull this into place. That's why I just tap it a little bit. You don't have to be violent with it and crouching and stuff. Anyways, how does that look? I'm checking on the microscope as I did before. It looks fine. Usually you just have to check two sides, you know. You don't have to check all four. Yeah, that's fine. So let me plug a charger and test this thing out. Before I do that, I'll just spray some alcohol onto it and try to cool it down rapidly. So as the alcohol evaporates, it will go with the heat. And that is the whole point. Let it cool down for a few seconds and then I'll plug the charger. I don't know, normal circumstances, trust me, I wouldn't have done that. I would not have done that. I would have just plugged the charger. I'm just doing it for the cameras. Otherwise, I would not. Nope, no result at all. 0, 0, 0, 0. So we come into voltage mode and we check here. That's a main power, and we've got 0.08. So we still don't have anything here. AC OK. Number 5, we've got 0. AC detect, we've got 3.5. So, and then AC in, still have got 18.9. Something is wrong here. Something is wrong, and it's pulling down this. This is not supposed to be 18. This I know for sure it has to be 19. And here it's getting this side now. At this point it is like 19.61. Let me try to find out on the board view how it gets here. How it gets here from the charger. So let me pause and find out how it gets to this point. because I'm getting 19.1 instead of 19.6. Yeah, it's fine. I didn't have to do that anymore. Anyways, I figured how it comes from the board view. Okay, let's try to focus that side. Anyways, so I checked it out. So from here, remember it comes over here. We've got like three double diodes here. So we've got 3 ports, 2 type C and 1 one USB charger. So if you follow this back, if you do this, it will tell you that it comes from this resistor. If you do this, it tells it comes from this one, and when you follow them back, they will take you back to the type C ports here. So that's fine, but we need to focus on this one. We need to focus on this one here. So that's the one we need to focus on, and when you check it out, it comes from this guy over here. And when we check this out, it takes us back to the charger, to our first MOSFET, first, second, and then the current sense resistor over there. No, that's a capacitor. I remember it's a capacitor. It's not yet the current sense. Anyway, so it comes to this fuse here, the very first fuse. So let's check those components before we get over there. But anyways, it doesn't make a difference, man. It doesn't make a difference because remember the type C charger is sending us 20 volts flat, and it's not compromising it at all. So I've just plugged the type C charger over there, and I know because I remember it was giving us 20 volts right over here, right around the BQIC. I need to see clearly there, 19.32. so it is giving me 20 volts straight. So the chip is receiving 19 and still ACOK is 0. So this has nothing to do with what voltage I'm getting here. So let's forget about that for now. That's okay. But I could just check for the sake of making things much easier later on. I know that I've already fixed that issue, even though the machine would probably work without me fixing that. So let me just check here. 19.65 is coming in, and what is coming in 19.65, and what's coming out of this double diode 19.13. so that missing 4 millivolts, 4 millivolts is dying here by this double diode. So that's not a big issue. We'll figure that out later on. We can always replace that. But now we need to know why ACOK is not coming out. Now this is becoming personal, because I believe now I'm probably close to an hour now. This is now 27 minutes. The other video was like 19 minutes. Do I have a short circuit anyway? I've got a 0 ohm here. Not so sure if that's supposed to be 0 ohms or what. Where's the BQ chip? I need to go and check the car anyways. I didn't park inside. That's ground. It's fine. So that is ground. And my ACOK, I'm not, it says extend power, so ACOK would come out and then go into that. It will come out of here and then go in there. So I just need to find out around ACOK if there's a short circuit somewhere there. That's okay, because that's a cap, so that's ground and that's positive. That would be ground and then that's positive. So I do not have a short circuit anywhere around here. No, that's fine. So what's causing us not to have ACOK? I think I'm gonna pause and try to do my research. Try and figure out why I'm not getting ACOK. Because I'm supposed to get ACOK. What could cause my ACOK not to be present? If possible, probably this guy is faulty. Because remember, there was some corrosion right around here. Yeah, I'm gonna measure also those resistors to make sure that they are still having good values according to the schematic as well. Alright, cool. I'll pause and resume later. Alright, guys. Luckily, I didn't have to stop the video and record again. I think I figured out where our issue is, or maybe one of the issues. So our issue is still around here, still around there. Yeah, let's take a look at the board view. So I was looking at the components over here. It's too much light. That is just too much light. Alright, let me reduce it like this. I hope it doesn't affect how I get to see the board. Alright, I'm gonna focus on the microscope over there, whilst we focus this side on the board view. So according to the board view here, I don't know how I can switch off that light. Let me pause and switch off the light, which you see at the back there, because I'm not even there's still some reflection, but it's not a lot anymore. Yeah, it's not a lot anymore, but there's still that one line over there. I hope it doesn't affect us too much. And I was looking at this over here, guys. Right, so I was checking all the components that were corroded here at first. So I've come across these two resistors over here. These two guys over here. So there's this one, it's got ground on one side. So let's check that out and make sure that we are in the right position. So I'm gonna remove the charger because the charger is still plugged in. Going into beep mode. Right, let me check. Alright, yeah, so this is the guy over here. I'm gonna check it out on the microscope. So it'll be these two guys. So that'll be ground and that'll be its friend. And then behind them we've got these two resistors which are kind of corroded, as you can see. So here we're supposed to be getting our V reg in 20. So if you remember, a BQ it's got a regen pin, but I don't think this is related because this is on the 20 volt side. Anyways, so checking over here, we're supposed to have a connection between this place and this one. So where we've got our voltage coming in from the chargers before it gets to the BQIC, because just after these resistors, remember, that's when it gets to pin number 28, which is VCC. So just before it gets there, we've got our guys here. So we've got a connection between here and there, and these two guys. So I'm just gonna check. I think I was probing the wrong spot, but I'm just gonna confirm if my theory is okay. Yeah, my theory is fine. So we do not have a connection in between from here to there. There's nothing at all. It doesn't beep. Look at it. It does not beep at all. So there, the probes beep. Let me try to bring this into frame, the two of them. The probes are beeping, as you can hear them. Then I'll put one pin over there. One probe over there. There, you can hear they are beeping together. But when you come here, there's nothing. There's no beep at all. So the connection which is supposed to come from here to these two guys here, it's gone. And this is the one that comes out from here into this resistor here. So this one has got ground on its other side, and then this other one, it's got the pin from here. And from here it goes into this think engine over here. I don't know what this think engine is for, but anyways, yeah. So let's just check before we reconnect there. Let's just check if we've got any issues around here, of which we do not. We just have ground here where we're supposed to have it, and everything else seems to be fine. So let's reconnect that. I'm gonna use a jumper wire. I'm going to use a jumper wire, and fingers crossed that will probably solve our issue, hopefully. Yeah, hopefully that will be the solution. Oh, I switched off the soldering iron a long time ago. Someone else was using my soldering iron, and they needed to use a big tip. So so my tip was off, and I switched it off so that I can put back the tip. I forgot to switch it back on, and it's gonna take a few seconds to get hot. I'm thinking of warming it up using a hot air because it's on 500. Yeah, let me do that. Let's see if that works. I'm watching the temperature there on the hot air meter there on the device itself to see if it's increasing fast. Yeah, it's just the same even if I'm not heating it up. So let's reconnect here. So this tip has been off for some hours now, and I see it has oxidized. So that is one side, and then the other side is supposed to come from here, right over here. Let us make that connection. There we go. We've got that connection there. Now we introduce our jumper wire from there to the side. Why is it that every time I work on a BQIC issue, I end up having to use jumper wires? Because there's a missing connection. Yeah, check the other two videos that I've worked on. Totally different issues. The other one, the machine was working, but it wasn't charging. Then the other one, the machine was dead, right? I think it was an ESA Predator from Russia. Yeah, the guy he was saying he comes from Russia, and his machine just went off while he was here in Cape Town, and he needed someone who could fix. What am I doing? Why am I failing to put a jumper wire? Right, so this jumper wire is supposed to come over here. So anyways, the guy says he needed someone to work on his laptop, and he found us online, and he brought his laptop. And the issue was, it's just wild, man. It ended up with me having to use a jumper wire again. Alright, there we go. We've got the connection restored there. Let's plug a charge. Oh, we've got response. We've got response, and we've got fan spin. Same time. Not even later on. There we go. We've got fan spin. Oh. Okay. Okay, now this is different. This is a totally different issue. I've never seen something like this before. Yeah, it is. It is drawing 1.84. This thing is on. It's running. It's alive. Whew. What an interesting journey. I'm just gonna put in a RAM, and I can feel the heatsink we're getting hot. Oh, this is nice. This is nice. You should have seen my face. Okay, there we go. Fan spin. Let me grab the HDMI. I hope it's not picky like a PS4. PlayStation 4s are just picky. They don't respond to this HDMI. I have to go all the way to the other room where we fix TVs from and connect from there. It doesn't want to respond on the monitors. The CMOS battery was off on this machine, right? Yeah, it was off, so that's why it's automatically starting properly. Yeah, you can see it's even drawing more now. 2 amps. Wow, that's a lot. 2 amps, and there's no battery at all. 3 amps. You see that? And then it has dropped down. I'm looking at the monitor there to see if we get a picture. But you can see, once you see a machine jumping up and down like this, yeah, there we go. We have a picture. Should have seen the bright red Lenovo there. Oh, this is nice. This is just satisfying. It's restarting. Wait for it to come. You know, it's been hot in Cape Town. There you go. It's a bright red Lenovo there, and this is fixed. And this machine is a Core i7 9th generation. So it's quite a, yeah, it's a workstation anyway, so anyone who would own this would want it to work if it went dead. I'm trying to see if I've got a USB keyboard close by so that I can get into the BIOS. Although I don't really need to go there. I can always just reassemble the machine. Yeah, just reassemble the machine and then we test from there. Oh, this has been a wild journey, guys. So what I'm gonna do is I'm gonna try to power it on using the Type C and not the barrel. And this one doesn't use a barrel. Dells and HPs use barrels, and the other Asus and the likes. This uses USB. What do we get? We've got fan spin. We've got fan spin. It responds, and the other port. Let's check the other port. Fan spin as well. So this is fixed, guys. This is fixed. It responds to power as expected. So for now, let's reassemble the machine. Ooh, and get paid early in the morning. See, so this is why I prefer to work on such complicated repairs at night, because I can pretty much think. During the day, you are trying to fix something, you have to stand up, go and attend to someone. You have to stand up, go and buy parts for another repair, and you know, just a lot, man. It's just a lot. Whether it's admin work, it's family, it's, yeah, you really, you can focus, but it's not as easy as it is at night to work. Also, like I was saying, it's been really hot in Cape Town, like extremely hot, and we haven't been really able to work during the day. It's been tough. I remember the other day it was very hot. I went home and I slept, and then I came back at night and I worked. Yeah, because now it's like I think it's around, yeah, it's 12 past 12 a.m. and you can see the fan there, it's on. And to think that this workshop, it's in a basement, there is no windows, there is no sunlight access, so this place should be really cool. During the day it will be cool, like it will be, you won't really feel the heat which is outside, but still you have to switch on the fan and the lights. Now imagine the people that are outside. Just the other day the temperature was on 34 degrees. Yeah, that's a lot. Your body temperature is 37 and this place is 34. At times it goes even higher than that. So yeah, anyways, I've pretty much put what we need in place for now. How do you sit? Alright, there you go. Don't be a nuisance. This LED here, which shows that your device is charging, is refusing to sit in place. Cool. I'm gonna pause for now. I'll just put a few screws and then resume, because this video is already 43. There's still 20 minutes from the first recording, so it's already an hour plus. So let me just pause and resume. Alright, so I've pretty much reassembled the whole machine. So I've put back all the screws as well as the battery, and also screwed it in. So I'm just gonna plug it in there so that I can see the machine charging. I'm pretty sure it charges. I don't think we have an issue with charging as well. Okay, it's probably gonna, it has automatically started. We know it draws typically around 2 amps. So if it's gonna start charging, it should start blinking there, because it will be going towards like what do we call it? Like around 5 amps. That's if the battery is empty. But if the battery is charged, then it will stay on its course. Yeah, I think you saw that just spiked up to 4 amps because the display has come on and it is also having to charge the battery. So this machine is on and it's working. I've just tested. This is testing its display basically. System order, and then it will restart and we have to go into BIOS. I love just seeing the specs so that I know what I fixed and wasted my time on is worth the time. Find out you're working on an Intel at home for like 10 hours. Core i7 9th gen. So much light on this place. Yeah. Core i7 9th gen. Yeah, that's decent, man. That's really decent. I just put a 4 gig RAM inside for testing purposes. This is a good machine. It's worth quite a lot. Yeah. Lenovo Thinkpad P1. I've never seen this. This was the first time working on it. Yeah. So just a recap of this. This was a BQ related issue, but then for some reason ACOK was not being activated because that Think Engine chip was not receiving the regen voltage, which is basically the voltage that comes from the charger. Yeah, so I'm gonna do my research on this chip over here and try to find out what it does. Yeah, because I've never dealt with this. I can see here when you're looking at the board view, you've got voltages like PCH SLP, which is like sleep, I guess. Suspend power, PCH sleep S3. This was S4 and this is S5. This is the one which was missing that we just connected. Switch off TE. I don't know what that is. Suspend on one and off. Regen from battery. So yeah, this was from the AC. This is from battery, I guess. Panel power. I don't know which panel. This extend power. This is where our it's related to our ACOK, because I remember ACOK was coming like this, and then it would be out here, and out here you can see it comes to this, and then we get this, which is what we are finding this side. Yeah, so there's battery drive as well, so it's related to power, guys. Shutdown, power shutdown. So this definitely is the reason why our MOSFETs are not active. Now I know. Now I definitely know. You see this power shutdown, this one. There's another one which, let me see. Let's leave the rest. For now, TC in drive 1, this one. So these two, I noticed them when I was looking at the schematic. Let me remove this camera. I noticed them this side, way this side. What's the name of that MOSFET? Let me try to zoom out. I'm forgetting which page it was anyways. Let me see. That's main battery connector. That's okay. From here, so this is where our charger comes in. If you look at the two MOSFETs, the two inrush limiters, they don't directly get the 25 from the BQIC. So you see DC drive in, there it is. DC drive in, the same, where is it gone to? There, the same voltage that we just saw coming from that chip, which was not receiving the 20. And then the power shutdown signal, there it is. It's also coming in. So these two MOSFETs would basically not be activated without those two coming from that chip. At the same time, we've got two more sets of MOSFETs. Yeah, so from the two Type-C ports. That's how I was saying, I don't think a BQIC would be able to power 6 inrush limiters, typically designed for 2. So yeah, I guess that's where we got confused there, because we were looking at it from the approach of having a BQIC powering 2 MOSFETs from the inrush, 2 MOSFETs to charge the battery, and 1 MOSFET from battery to the system. So yeah, in this case we had 6 dedicated to power from charger to the system. So that's why we've got that Think Engine there. Anyways, I'm hoping that you guys learned and enjoyed something in this one. It was quite interesting. I'm just gonna shut it down now. Just gonna shut it down to make sure that it's charging. So let's press the power button, hold it. Now it's off. Let me see how much current it's drawing. Hopefully the battery works. Yeah, if it doesn't charge, then I'm gonna do a video of it charging, but I'm pretty sure it's charging. I'm gonna plug the battery to the power supply to the programmer there, to the battery programmer, and see if it's okay and all that. Because right now I'm programming this battery here for a ThinkBook. So it's been Lenovo's tonight. Anyways, thanks for watching, guys. This is it for now. I will see you in another video. Cheers and goodbye.